Hello everyone, it's Benny, and welcome back to the 3D Game Engine tutorial series. Last time, if you remember, we were working on creating a system that could automatically add attributes to our shaders, which is great except for one small thing. It doesn't support structs. So that's what we're going to handle in this video. We're going to make our shader system support, well, struct types specified in our shader. Get all the special struct syntax in there. And yeah, let's go ahead, dive in, and get started. Now, the first step to finding the structs is knowing what structs we've defined. So I'm going to write some code that goes through and figures out what structs have been defined inside the shader source. So I'm going to create some public function. I'm going to call it public void. Actually, I'm going to make it private. This is going to just be used inside the shader class. Private void, and it's going to be called find uniform structs, except with the lowercase. And it's not going to be void. I don't know what I'm thinking, but okay. And it's going to take in some string shader text. But what it's actually going to return is it's going to return a hash map. The key is going to be the name of the struct. Well, here, let me actually show you what I mean. The key of the struct is going to be, well, the actual name. The value is going to be a list of these, the names of the components. That way, it gives me a fairly easy way to reconstruct things like, well, directionalight.base.color, or, chains like that. So yeah, going to be a hash map of string to array list of string. Kind of an interesting hash mapping formation, but hey, it'll work. Or, actually, maybe I don't need array list. Maybe I can... I haven't thought about that. Oh well, I'll see what's more convenient in the end. I suspect array list will be. But yeah, it's also going to use code very similar to what I have in add uniforms, except it's going to be, well, struct keyword. It's going to be in, like before, I'm going to copy it directly out of GLSL, struct, just to make sure I don't do some wonky typo, like I did with attribute keyword, key or rod, or whatever I did. And, yeah, sprinkle struct around instead of uniform so that the names are more appropriate. Struct start location, struct line, struct name. I don't think I'm even going to keep that part, but I'm going to keep doing it anyways. Struct stuff. Oh boy, more replacement. Struct, and struct. There. Now, of course, this isn't actually how... Actually, wait, will this work? Huh. Well, because I just realized structs do end in a semicolon, and the name is the second part, but no, that's not going to work. So, yeah, I'm going to want to make a few changes to this. For instance, the beginning of the struct isn't just going to be the position... Well, how about this? The name begin is going to be that. It is going to be just, well, the length of the struct keyword plus a space, because, well, that'll be where the name starts. And I'll say int name end. That's going to equal, well, now this is going to be a little bit tricky. Well, actually, it's not going to be tricky at all. What am I saying? Okay, how about this? Struct, brace begin. How about that? Why not? Trying to think of a good name for this, but yeah, what I'm looking for is wherever the opening brace is. Looking for the opening brace of the whole thing. Yeah, the opening brace of the struct. There we go. And that should be, well, the index of the brace. And there. Now struct name is going to be substring. What I'm trying to get is something right here. Now the cool thing about this is that no matter how you format your structs, there's always going to be one character between them. One of them's going to be a space, the other's going to be a new line character. Well, maybe a new line character and a space, but, you know. So, in theory, I should be able to just say struct name will be equal to, well, the substring of brace begin, name begin, to brace begin minus 1. Again, that's not a very general way to do it. You'd probably want to find some trailing whitespace remover thing. Or, even better, isn't there some function like, I don't know, it should say shader text like this, isn't there some function like .trim, which removes whitespace? Oh wow, I didn't think of that. Hang on, I should probably just go through add all attributes and add all uniforms really quick, just to see if there's anywhere I could be, using the trim function to make things a little bit more general. And I looked, and yeah, there's quite a few places that could benefit from trim and just better parsing code in general. But, since this is supposed to be a tutorial on a 3D game engine and not how to write the most graceful parsing code in the world, I'm really not too worried about it. If you want to learn how to write amazing parsing code, then hey, I'm not against teaching that sometime. Just, I don't think I should teach it in a series that's more focused on how to make a 3D game engine. I want to do what's necessary and then move on. So yeah. And also while I was gone, I realized that I made a slight mistake here. I forgot to start at the name beginning. Yeah, because otherwise this would find the first opening brace in the entire file, and that's not what I want. So yeah. And I'm also going to have, while I'm at it, one final brace position, which is going to be shader text.index of and closing brace, starting at the brace begin, plus 1, just because, well, why not? I'll start at brace begin. I don't see why it would cause an issue if you started at, well, where is it? Yeah, if I started right here, rather than right here. But just in case some odd ball edge case causes a problem, all that stuff. So there. Now we know where the brace begins, where the brace ends. We know what the structure's name should be. All that's left at this point is to add all the different components to it. So I'm going to do this with, guess what? I'm going to do yet another sort of parsing thingamajiggerton, like where it's like the parsing while loop index of thing. So I'm going to start off by just declaring an array list. It's going to be an array list of strings. I'm going to call it struct components. Just going to be new array list of strings, nothing to it. I'll put it right under struct name. And here's how our sort of while loop thing is going to work. The easiest way that I've found to find the name of whatever component is very simple. The semicolon. Because the name's always going to come just before the semicolon. So that's what we're going to do. We're going to find the next semicolon, backtrack until we found a space. Take that substring, that's the name. Then find the next semicolon, backtrack till we find a space, and that's the name. Find the next semicolon, oh wait, it's outside the struct, but we know where the brace closing position is, right there, so that's easy to detect, and we can just end right there. So that, ladies and gentlemen, is how we are going to be detecting all the struct components. So let's go ahead and get started. I'm going to have some end I'm going to call component semicolon That's going to position. Sure. Or pause, how about that? Just so it don't get a name that's 10 million characters long. And that's going to equal, well, shader text dot find, or index of. It's not called find in this language, excuse me. I'm going to find the semicolon. And it's going to start at the brace beginning. So just start at the beginning, we're going to find the very first semicolon. And then we're going to do the while loop. While this position is not equal to -1, because, well, that would mean it's not found at all, and while the component semicolon position is less than brace end. Because, you know, if we're past brace end, we're outside of the structure in the code, and then we can just end right there. So there. And now I want to go ahead and start with my condition that's going to be at the end. It's going to start at component semicolon position +1. There. So great, we've got yet another one of these while loop things. It's going to go through the structure and find the semicolon. So what do we do now? We're at the semicolon position. What do we do? Well, very simple. Our next step, now that we know where the semicolon is to backtrack. We're going to backtrack all the way until we've found whitespace. So that's exactly what I'm going to do. I'm going to create some end. I'm going to call name, or component name start. That's going to start off equal to component semicolon position. And actually, while I'm at it, I can go ahead and create component name end, which is going to equal component semicolon position minus. Actually, no, add the component semicolon position because, well, that would be right here. That would be the end of the name. Never mind. So, yeah. In fact, I don't even need that variable in that case. So, never mind. I can just, well, I'll leave it there just for clarity's sake. Nah. Okay, I don't need it. I'm going to get rid of it. It's just cluttering things up if I leave it in there. So, the name starts off here. And I want to backtrack until I find the space. So, while component name start is not equal, while shader text .char at component name start, there, is not equal to space. You know, we're looking for white space here. And yeah, theoretically, it could be tabs or whatever other white space character of your choice is. Actually, I wonder, does Java have a character test that's... I won't worry about it. I'll save that for if I ever do a tutorial on actually parsing things seriously. I just want something working right now. So I'm going to go through the while loop. It's empty body. That's fine. Doesn't matter. Because I'm about to fill it in. And while this is the case, I'm going to say component name.start minus minus. We're going to go backwards. Going to keep backing up. And there. Whoop, nope. Trying to delete the semicolon, or not the trying to delete the closing brace because I don't need it anymore. And after that, I'm going to say component name start. Actually, even easier. I can say, rather than adding one at the end, because, well, at the end it would be right here. It would be at the location of the space. I want one more for the start. Rather than that, I'll just test the position before the component name start. One before that. There. And at that point, I can very simply do struct components dot add. I'll add another one, and it's going to be shader text dot substring, starting at the component name start and ending at the component semicolon position. And that should be the name. And just for debugging purposes, in fact, just for debugging purposes for the time being, I'm going to go ahead and print out a line that says the name of the component. So, yeah, it's going to say this. And there, this way we'll know if our code is working. We should see the name of every component in every struct. And it's not a perfect way to know if it's working, but, you know, it's there. So good, at this point we should have all the components added to the struct, and all we should need to do... Oh, I completely forgot about that. Excuse me. I need to create a result hash map. Hash map of array string to array list of strings. Going to call it result. Was the new hash map of all that nonsense. And right here, I'm going to say result.put. I'm going to put a key with struct name. That's going to be the key. And the value is going to be the struct components. And at the end of everything, I can just return result. And there. And I'm going to create a hash map of all that nonsense that I'm going to call structs. And that's going to equal find uniform struct shader text. And I'll use that to detect whatever in a moment. But yeah, let's build and run. Make sure I haven't broken anything, first off. And there, good. Haven't broken anything, but I'm not actually using the code. Well, you know, to actually find a struct. So, in forward directional, let's comment out everything that isn't, that isn't the directionalLight.base thing. Let's do something sort of like this, where we're adding based on, well, you know, we have the copies of the file, you know, the full text of the file. Like this. And I could go ahead and auto-add attributes, but I just want to focus on this right now. I'm going to call add all uniforms. Now this is going to crash. Unless I've really done something good. I don't think I have. This is going to crash. Because it's still going to try to add directionalLight by itself as a uniform. So, yeah. But hey, it should print out all of the different uniform names into the console. And, hey, look at that. So what's directionalLight including? Wherever you are. directionalLight.fs. Oh right, it's including light.glh. Of course. So, it's getting color, intensity, constant linear exponent. It's getting the base and direction, the base attenuation position, range, and looks like it's getting everything. Good. Excellent. Outstanding. It appears, at least in one of the most significant ways, our code's working. I'm guessing, yeah, could not find that uniform. That's okay. So, in fact, yeah, while I'm at it, I'm going to call add all attributes with vertex shader text. Just because I can. Notice how this is getting to look suspiciously similar to the code in our forward ambient. In fact, it's exactly the same minus the file name and the commented out code. But yeah. So let's go ahead and keep working with our add all uniforms. Now that we have our big hash map of all our structs, we can do a little check here to see if our uniform type is a struct. If it is, we can start adding uniforms based on what's it called? I'm looking for something here. We can start adding uniforms based on like the dot notation, where it's directionalLight.base.color. You know, like that. Except I forgot something. Let's look at our directionalLight, sure, and our shader. What happens if in our struct, one of the components of the struct, one of the types of one of the components, is also a struct? Yeah, we're going to need to handle that. So, yeah, we're going to also need to store the type of whatever thing we're dealing with in our find uniform structs. So, wonderful. I'm going to create an end I'm going to call component types end, it's going to equal, well, component name start -1, in theory. Again, I'm only supporting things which only have one space between them. Probably not the smartest way to parse things, but you know, it works for a quick and dirty parser. If you want to write beautiful parsing code, this is probably not the place for it, in case you haven't recognized it already. And I'm also going to have some component name start, which equals, or component type start, excuse me, which starts off equal to component type end. And now this is where things can be a little ambiguous, because, well, it could be equal to, oh, just equal to spaces, there's no tabs in here? Okay, well, that makes things enormously easier. But, well, or, hang on, I just got an idea, and I want to see if it's going to work. One moment. Ah, yes! Java has a function to test if a character is whitespace, so let's change a few things. Let's not make this not equal to space. Let's make this if not character dot is whitespace. Because, you know, we want to know if that character, while that isn't whitespace. And same sort of test here. While not character dot is whitespace. And we're looking for shader text dot car at component type start. Yeah, -1. Put all sorts of closing parentheses. And while that's not the case, component type start --. And what do you know? That'll put the component type start right at the beginning, right where I want it to be. Wow, that just makes things so much easier. I love it. So, now that we've got all that, now that we have, in fact, no, let's just break this down a bit to make it a little bit easier. I'll have component name, which equals what we have, sort of like, stop it, you're getting in my way. Which equals this thing right here, what we had before. And I was going to have a line for component type, which, same thing, except substring is with component type start and component type end. And just to make sure our code works, and crash the program again, I'm going to print out component type this time. Just because I want to see this work. This is going to be awesome. If it does. Should work, but... Yeah, look at that. Actually, wait a minute. Hang on, didn't the component name last time have some sort of, like, space? Or was that just the way it was formatted? Hang on, I want to test that again. Component name, does it have some weird spacing issues, or is that just... Okay, no. That's just the way it was formatted inside the error message for some reason. But yeah, wonderful. Look at that. We have component names and component types. And they appear to be working out just fine. Now the only thing is, how do we return that? And here's how I'm going to do it. I'm going to return an array of array lists of strings. Yeah, I'm making a hash map of that maps strings to array lists to arrays of array lists of strings. It's one hell of a type, but I think this is what it takes to work, you know? And it's going to be an array of two things. The first one's going to be the type. The second one's going to be the name, or maybe vice versa. I'm not entirely sure yet. It can be either way, really. But yeah. So I'm going to have two array lists. One's going to be of struct component names. The other's going to be of struct component types. And yeah. And now I'm going to add new array list of string array here of size which takes in struct component names and struct component types. This is getting to be some This code is getting a lot more complicated than I expected it to be, but oh well, that's fine. Generic array creation? Does Java not allow that? Huh. Well, in that case, one moment. I could have sworn Java allowed you to do something like that. Okay. Apparently, the almighty Java has decreed, "Thou shalt not create arrays of array lists." So, this doesn't happen. In that case, let's do something a little different. I'm going to create a private class. I'm going to call it Struct. Sure. Okay, how about this? GLSL Struct. Yeah, sure. How about that? That works. I'm going to create a private class, and it's going to basically be a struct. It's going to have a public string name and public string type. There. This way, it's hopefully a little less monstrous. Is that what the word I'm looking for? I think that is, yeah. A little less monstrous than what I was doing before. And, it actually works. So yeah, instead of that, it's going to take in new GLSL struct. Actually, wait. That doesn't work, does it? Right, Java doesn't do that. Never mind, I'm thinking of C. I'm going to have a GLSL struct. I'm going to call it... Oh, what should I call it? GLSL struct. It's going to be a new GLSL struct. And the name is going to be, well, the component. Oh, right, I'm making... Never mind, I'm going to have to change things around, but yeah, I want the name to be the component name, and I want the type to be the component type. And, I actually want the code to be here, not wherever I was trying to put it. Yeah. I'm going to have an array list of GLSL struct. I'm going to call it GLSL Structs. And that's what I'm going to add to the result. There. And all I should have to do at this point is say, right here, right below the GLSL struct stuff, GLSL structs dot add, just need to add our GLSL struct. And there. I think that should amend everything. I think this should be a system that Java actually accepts. And I'm going to double check to make sure. At least I probably am. Maybe I'm going to get lazy and not, but probably I'm going to double check and make sure after this. Yeah. So there. This should put all the component names and component types, which we've confirmed are working, in the struct, add that struct to the list, then at the end, after we've added everything to the list, put that in the hash map. There, good. All the logic should be sound here. And with that, we should be able to finally start doing the test about whether or not to add the uniform name, or whether we need to sort of append to it. But wait, there's more. Because how do we access the struct hash map? Well, the key is the struct name, right? Well, the struct name would be the uniform type. So yes, ladies and gentlemen, we are going to need the uniform type. So here's what I'm going to do. I'm going to create a string. I'm going to call it Whitespace pass. And that's going to be equal to this. Well, sure. I'm going to find the uniform name at Whitespace pass plus 1. Wait, int Whitespace pass, never mind. I'm going to find the uniform name at that, at Whitespace pass plus 1, like before. And I'm going to find the uniform type at uniform line dot substring 0 to Whitespace pass. And there. So now I got the type And now I can do something like, I don't know, array list of GLSO struct. I'll call it struct, wait, component, how about this, struct components. And that can be equal to structs.get at the uniform type. Of course, we're going to need to do more checks after this, but hey, at least we're finally accessing this big, gigantic hash map of doom. That said, I prefer to do this slightly differently. I'd like to have a private function. Private void, I'll call add uniform with struct check. It's going to take in some string uniform name, a string uniform type, and finally, it's going to take in a array list of GLSO. Wait, it's going to take in the hash map of string to array list of GLSO struct called Structs. There. And this is where I like to do the check. So I like just replacing add uniform with the function add uniform with struct check, taking in uniform name, uniform type, and structs. And here's how this works. What I'm going to do is very simple. I'm going to have some boolean called add this, which starts off equal to true. And if I add this, then I'm going to add uniform with the uniform name. But here's the thing. If my struct components is not equal to null, then two things. One, not going to add this because, well, you know, this isn't null anymore. And secondly, I'm going to need to call this function again, call it recursively with a new uniform name, appended with like a dot and whatnot. Because, well, we've got more struct components. In fact, I'm actually going to have to iterate over them. So, yeah, this is going to be fun. For each GLSO struct, in, call it, I don't know, struct, in struct components, well, here's what I'm going to do. I'm going to say add uniform with struct check for uniform name, because you got to add the dot, you know, like in direction light. Going to take, well, not sure what I did there. Oh, right, all that stuff. Yeah, that can be ignored. What I'm actually looking for is something like this, where it's the old uniform name plus a dot plus the struct.uniform, or struct.name. Yeah, it's going to have the type of the struct, and since it's recursive, it's going to perform the same check, and if it's like something like a base light, it's also going to do this there, and also going to have the structs list. And that, I think, considering just how ridiculous it is to get all this working, I'm not going to say I know, but I think this is actually going to work out. Finally. So, let's build. Let's hope we haven't crashed anything. And let's run. And what do you know, folks? Directional light is working. The uniforms are being created and updated, so the code is working. And that just means there's one final thing I'd like to do before I end this video. And that is, I'd like to change our sort of, our shader constructor, if you will. You know, I don't want it to just be, oh, it's a new shader and whatnot. I want it to take in a name. I want to have some more meaning than this. So it's going to take in a string file name. And it's going to do something, well, a lot like what our forward directional and forward ambient are doing. Because, well, look at them. they're literally doing the exact same thing in the constructor now, except for, well, the file name. So I am going to copy all this. Going to copy it. Going to change it to, well, file name plus .vs and file name plus .fs and whatnot. Because, you know, got to actually make it a little bit more generic, make it handle different, you know, different extensions and whatnot. Sort of side effect of this is we are actually committing to the VS and FS extensions at this point, but hey, you can set that to whatever your preferred extension is. I'm not stopping you. And yeah, that means now I should be able to just have the constructor as calling super with forward ambient. Or better yet, I can just have... Can I get away with having no constructor and just saying forward ambient here? I'm curious. Does that let me? No? Okay. Well, in that case, I'm going to make it like this. And this one's going to be sort of the same thing, except with forward directional. And yeah, this is how I'm going to handle all the rest of my shaders now. Because no need to. Well, the shader class itself already handles adding and setting these things automatically. Nothing needed. So, yeah, I can say forward point here. And if I build and run, everything should just work. Look at that. Look how much easier that is. We've definitely taken a big step towards making totally generic shaders at this point. Okay, so I went ahead off screen, and I added a few checks to our parsing code to make it a little more versatile, handle more cases. It's still not perfect, but it's pretty good. So yeah, and I'm not going to talk too much about this. I'm going to go through it sort of quickly, just because, you know, this isn't really a parsing tutorial, a 3D gaming tutorial. But yeah. First thing, actually I'm going to start in Struct, because I think this is where this example makes most sense. How do I know when I found somewhere where it says struct that it's actually the struct keyword, it's not part of the word like construction? Well, that's why I'm doing this check right here. It's making sure there's either a white space or a semicolon before it, and that there's white space after it, because otherwise it's not a valid use of the struct keyword. It's just being part of some word, like instruction or something. And yeah. Now, I'm doing the same sort of check in attribute. Don't know why attribute would be in word, but hey, doing the check anyways. Now, when I'm actually extracting the line, the attribute line, you know, the thing that has the type and then space and then the name, I'm trimming this, so that way I'll get rid of any white space before or after that line. And yeah, so there's only going to be white space in the center. And that guarantees that this call, right here, will find the white space in the center, and that this will find the attribute name. That doesn't stop extra white space from being in the center, though, so I'm still using .trim on this, just to get rid of the extra white space. But yeah, I'm doing that. And that's all I've done with attributes. And I think I also did something very similar with uniforms, because it's a very similar function. I'm checking, again, making sure uniform's not part of a word. I am trimming the line, and I'm also trimming the uniform name and type here, just to be sure there's not any extraneous white space somehow. And yeah. Now with Struct, I'm doing something a little bit interesting in here. I'm actually starting from one after the semicolon position, making component name that is, and then counting backwards as long as either the character is white space or it's a semicolon. This way I'll just sort of skip over all the white space characters and moving the component name end past all the white space characters, whatever white space characters might be there. I'm already doing the same sort of thing with Struct, make sure it's not white space, so yeah, this is guaranteed to encapsulate the component name. Component type in, I'm doing the same sort of check, going backwards as long as it is white space, just to make sure that, you know, any extraneous white space in the center is skipped over. So yeah. And that's all I did. At least I'm pretty sure. Yeah, that's all I did. So it's just making sure there's no extraneous whitespace being caught in it. And there's still a few things it's not handling, just because, like, well, right here, I'm checking for an explicit space character, not something like a tab or or a new line character, so it's technically possible for this to screw up still, but I'm not that worried about it. These are just a few things to make it a little bit nicer, a little bit more versatile, and I'm not too worried about these issues. You can fix them if you want, I'm just not too worried about it. So yeah, although there's actually a few more things I want to do while I'm at it. I want to get rid of, or not get rid of, but rather make private all these functions that I'm not going to need in public anymore, like, well, add all uniforms. Don't need anyone else accessing that. Or add uniform. Or, really, not even using these anymore. You can make all these private, private, private. Yeah, this is private. Compiling shader, private. Adding programs, private. Loading shader can be private now. Just making everything I feasibly can private. Only thing that isn't private is setting uniforms. And in effect, that means the only thing that isn't being done by the shader class itself is setting the uniforms. So that is going to be our next goal and our next challenge. Making a fully generic update uniforms function. Because right now in our shader, yeah, look, nothing in update uniforms. We're not even trying to handle it. What if we could have a totally generic update uniforms function? One that would handle absolutely every case out there. There's no way that could happen, right? Well, I think you'd be surprised. Thank you. Hope you enjoyed. Hope you learned. And I'll see you in the next video.